Hello, and welcome to Follow Your Curiosity, where we explore the ups and downs of the creative process and how to keep it moving. I'm your host, Nancy Norbeck. I am a writer, singer, improv comedy newbie, science fiction geek, and creativity coach who loves helping right-brained folks get unstuck. I am so excited to be coming to you with interviews and coaching calls to show you the depth and breadth both of creative pursuits and creative people, to give you some insight into their experiences and to inspire you. Michael Smith is a software engineer who has held product positions with Google, fuboTV, and most recently, Prodigy Finance. He's also an avid amateur musician and actor, and I've known him since we were in 7th grade together. I've been trying to pin him down for an interview for a while because I really wanted to hear about his experience balancing such a technical field with the arts and how software engineering goes beyond strict logic and into creative territory. I asked him to explain just what the now ubiquitous algorithms we hear about are, and we also talked about how he chose the technical over the arts as a career, how the two influence each other much more closely than you might guess, and the link between mathematics and music, plus a lot more. Fair warning, we get fairly deep into the weeds of how both work, but even if some of the technical details escape you, like they did for me, I think you'll find the conversation fascinating. Thanks for coming and talking to me today.
Yeah, no problem.
I've been curious because obviously we've known each other for a really, really long time, but I don't actually know like how you got interested in programming, and I don't really know what the heck is creative about programming, so I'm really hoping that you can help me out there.
Okay.
But I'd start at the beginning.
Yeah. So I got into programming actually, like, gosh, I was programming probably in like middle school, right? Like, So age 6, I think I probably got, at first I had like a TRS-80 color computer too, way back when. And I would get magazines and then type in the code from that and then make it do something. And I think what's interesting about software is I think it's not too so anyway. So then let me stay with that story actually.
Okay.
Rather than jump into because I kind of want to talk about what's creative about it too, because I think it is when it's done well. But I kept with programming because I just enjoyed making things go and essentially creating new things, but in like a more dynamic fashion. So the really nice thing about software is it's pretty self-contained. So you can make it do whatever you want it to, and there's ways to do that. And so it's a bit like having a Lego block set made out of logic.
Ooh.
that you can kind of like mix and match, and when you get good at it, if you understand how like you can take something between mathematical proofs and like Lego blocks and stick them together and make lights go, right? That's what programming feels like when it's doing it really well. It tends more towards engineering when you start talking about solving actual real world problems, and you really care a lot about the way in which you approach the application of it, and then it becomes very constrained and not terribly creative. But even when you're doing that, there are usually a multitude of approaches to it. Like I think a lot of engineering can still be very creative as long as you've got multiple avenues towards whatever it is you're trying to achieve. Sometimes it's so highly constrained, you're left with only a couple different options. The beautiful thing about software is that the ability to mix and match your clay, right? Your different materials. You're not building architecture, so you're not using giant girders of steel. So for you to kind of like rip the whole thing down and build something back up in software is fast and easy. And if you get pretty adept at it, you can have software leveraging your own software. So either you figure out how to make a pattern and replicate it. There's techniques such as like recursion or like really good design patterns that allow you to kind of very simply put together a couple things to make them very powerful, and therefore kind of like move up the complexity very quickly. which allows you to build sophisticated things very, very quickly and neatly. And so when you get to that level, then you can be very creative, and you can draw a lot of logical analogies between what you have done before, and like you can map one problem onto another one and realize it's kind of a mirror image of a similar problem. So you just switch the problem around, and then actually you can solve it a different way. You get taught this a lot in like algorithms, where you can, you've got one classic algorithm and it's meant for this kind of thing, but you can apply it over here just as easily. And sorting is a kind of a bad example there, but there is another kind of example that's actually very good but very complex. There's a thing in software where you can prove that something is a certain level of computational complexity. So whether it's Turing complete or not, and in order to do that, you map a program onto another program, and you figure out how you could use one program to make the other program run, and that proves that they are of the same complexity. So it's a bit like mathematical proofs, but with all the like tangibility of like an erector set.
Okay. I have to admit there's a lot that's in there that you just said that I'm not entirely sure I understood, but it does occur to me that maybe you can, I feel like we hear the word algorithm all the time now. Facebook has its algorithms and Twitter has its algorithms and everything's got an algorithm. And I think probably most of us have this vague sense that an algorithm is something that controls something else, but I don't think we really know beyond that what that means. Can you explain it?
Sure. Well, I can try. Okay. I mean, there's clearly textbook answers, but to me, an algorithm is a set of instructions to do something.
Okay.
Right. And the way in which you approach it really is important. So, and that's why the algorithm is so important. So if you decide to, let's say, run your errands just in the way that you wrote them down, right? Like that might mean that you're running around town with no efficiency whatsoever. Well, you could also sort them in some way, shape, or form, maybe from left to right, but your map is two-dimensional. So maybe you should instead sort it by maybe the smallest distances from home first, or like, what are you trying to optimize for? Are you trying to optimize for the number of round trips? Are you trying to like optimize for speed? Are you trying to optimize for your gas usage? There's all these different techniques you can use to try to figure out the different algorithms you use to approach the problem. And this gets increasingly more complex as you throw larger mounds of data at this. And when you put machine learning into it, it becomes significantly more complicated as you go as well. So all of that is to say that the algorithms usually are almost a trade secret within the company, but we all kind of know roughly how it might work. And then that's usually at the industrial level. At the very practical, like just learning software 101 level, there's just a course in algorithms, which is you start with some very simple. Here's a couple for loops in a couple ways, and here's the most naive way you can sort something. And then here's a more complex way to sort it, and here's an even more complex way, but it becomes more sophisticated and faster. And then if you can make certain assumptions about what it is you're sorting, you can sort it even faster. And kind of learning how to leverage all that up, and kind of how that works in the real world. And then the socioeconomic implications of this at scale become extraordinarily important. And that's I think what's most important about algorithms today, actually.
So basically they're tools that help you solve a problem.
Well, it's a set of instructions, and it's the way in which you apply those instructions.
Okay.
Right? And as you can see, there's multiple different ways you can build up those instruction sets. And those are different algorithms, and those have trade-offs between them.
Because I'm kind of thinking, just from my own experience in IT, that there is a certain creativity in problem solving, because you kind of have to think beyond, if you're trying to, sort out why somebody's computer doesn't, print correctly or whatever, which is a shockingly simple example compared to what you were just talking about. But still, if you've tried all of the usual things, then you have to keep looking to figure out what else it might be. And it might be something completely unexpected, like this little utility that you installed over here that's messing with your printer driver and stuff like that. And so yeah, I mean, I think part of the reason that, I asked what's creative about programming in the first place is that it is so logic based. And so we tend to think of it kind of like we think about doing a math problem, like where's the creativity in doing math? But I think it's hidden in there. I think
it's less like a math problem in like addition. Than it is like, one could say that actually like proving a theorem for the first time. That is extraordinarily creative, because what you there are rules that you need to follow, of course, but you really work on your like latitudinal thinking to be able to kind of problem solve it from multiple different angles. You're either trying to create analogies, or you're trying to like explore the mental space of the problem, and you're trying to address it with a multitude of different things. Like in your example of the printer, you probably go, okay, well, it's probably this, just by experience. Okay, that's just raw engineering, right? That's just, I've done this before. I'm going to apply a known problem. But if that ends up not working, you end up having to be much more expansive in your thinking and much more lateral in your thinking. And you end up kind of like, you think of all the potential options, and you kind of even invent like somewhat mythical options, sometimes just for kind of stimulating your brain to try to break it out of the way that it's thinking about the problem. Because I've seen a lot of people in technology, you can make a really bad solution in engineering by going at it straightforwardly and head first. In a lot of design, that's called like a fragile design, right? Because it like you've kind of done it naively, which then the second that the problem becomes a little bit different than the one that you were trying to attack naively, you don't have a robust implementation to solve the problem. It becomes fragile and it falls apart. So, for example, if you just have a checklist to fix your printer problem, that will work if it's on the checklist. But like it won't say, check to see, like the way to abstractly think about your printer problem is you're trying to send data from your computer to your printer. Well, what are all the ways in which that can happen? Right? It could happen the way that it works is the data goes from here to here. So then how do you kind of figure out what the problems are between there and there? And what's interesting is the more abstractly and creatively you think about it, the more robustly you can handle a generic printer problem. Like it could be a computer you've never seen, using a network you've never seen, using to a printer that you've never seen. But the data has to go from here to here. And there's only a couple set ways in which that can happen. And so then you build a really robust mental model about the way that would happen, and then you dive into the specifics, and it's fine. So I think engineering, particularly when you wind it back to kind of first principles and what you're trying to accomplish, you're kind of trying to do something a lot more creatively than kind of mechanically.
Mm-hmm. Yeah, I think that a lot of people think of programming as just trying to sort out raw logic. And certainly, I'll admit I am as guilty about this as anybody, because back when I was a senior in college, someone talked me into taking Pascal. I don't know why. It made the last semester of my senior year just a nightmare. and I remember, these simple things that you take for granted. I remember this one problem, and there was a really nice guy down the hall from me who kept trying to help me wrap my head around it. It was just, you had, single digits, 0 through 9, and you were trying to move one to the other end of the row, which is super simple when you're a human being. You just rewrite the list and, put the 0 at the end. But when you're trying to make Pascal do it, it's phenomenally frustrating. And I can imagine you laughing at this, because it's got to be completely elementary and basic for you. But for me to try to actually break that process down was you might as well have, expected me to do nuclear physics in Martian. It was just completely beyond me, which obviously is why I remember it so well. So,
well, what's interesting about your example is that I think it's actually, you were given a Pascal problem that's a lot like teaching someone only the pure mechanics of mathematics, which like I know you were good at math, right? So it's like there's nothing. The mechanics of math aren't the point.
Mm-hmm.
They're the way you get to the real fundamental problem, which is like the understanding and the representation of something real. And I think, unfortunately, your first class in software development almost always has to be the kind of get through the horrible semantics of just how to make the damn thing run, which is kind of like, it's the wax on, wax off of like, of like computer programming, which is like horrible. And then only eventually you realize when you get good with that you can actually do something much more interesting with software development. And that's the point. It's kind of like, I know so many adults who kind of struggled with algebra and they never got onto calculus. And then what's really amazing is you just like, you move two things relative to each other, or you change like, the shadow height of a moving object or something. And just like, that's what calculus is for. It's so like ingrained in our world and our DNA that you can get your head around the concepts, but the mathematical representation is really hard. And you almost should be kind of teaching both at the same time to be able to get your head around it. So I think people should almost be teaching very abstract logic, almost the same time they're just teaching you this is just how to make Pascal just kind of go. And unfortunately they don't, because the one is super interesting, the other's just here's how you pick up the hammer and swing it. And it's you really want the more interesting one. But you kind of have to know enough. I mean, I guess the same thing's true of like music. I'm trying to play guitar right now, and like, I know what I want to try to accomplish, but like the mechanics are just super frustrating. And part of that's because I've done enough music that's not like I know where I want to go, and I know I just have to fight through the mechanics. But I know that because I'm on the other side of music, but like, and software development's a little bit like that too, where I don't know, like I know how to code, but I think I've been in it long enough that I know how to abstractly solve a problem. And I happen to have code as a whole set of toolkits, but I can also use all kinds of other code or other techniques than code to try to solve the problem. Like some technology problems, I just whip out Google Sheets, make some computations, and say, right, that's done. They're like, well, did you write a program? No, I don't need to write a program. Like, it's done. Like what? I understand it, and like that's all that we really need. The problem doesn't need to be any more robust. And if it does, then I can take what I learned by doing it for real and like actually institutionalizing it later by kind of putting it into code. But doing it mechanically is kind of maybe the most important thing in that particular instance. But like, I just know how to solve generic problems, and I think that's the core of engineering. And you just learn the most beautiful thing about software as an engineering discipline is that actually the clay is so fluid, and what you're passing through it, like the data and information you're passing through it, is also so fluid, so you can remix stuff in a much more creative way than many other disciplines allow you to do.
Wow. All right. It's funny because you also have me thinking about how a couple of years before I took Pascal, fool that I am, I also took a logic course in the philosophy department, not realizing that they were basically going to ask me to do math with words, which was going to make it even worse.
Yeah.
You know, and that was after taking calculus 3 times in order to get, a grade on a transcript, or not a grade, credit, because I had to transfer it, but after failing calculus. So there's life after failing calculus. But I never got to that whole shadow thing that you were talking about. I just got to, oh dear God, when's it over? But yeah, logic was just, oh, what am I doing? And I think logic for me was probably like physics. Like, I find physics absolutely fascinating until you make me do math with it. You know, like the concepts of how things move and how things behave and stuff like that, I think is really, really cool. And then, you know, Milt Bushy would make me do math with it, and that was where it all fell apart. So.
Yeah. And I think there almost should be there'd be a huge value to many adults who don't like the specifics of mathematics to still be able to take and understand mathematics and physics and chemistry and a lot of sciences at like kind of at that kind of almost appreciative level. But I'm not trying to dumb it down, really.
Right.
Like, I'm not trying just to know like so many things in physics, for example, are just pendulums. Like springs are pendulums. You know, a circle can be described as a pendulum. There's a million different ways in which all this stuff kind of interrelates. And for you just to kind of be able to get that instinctual feel and see how the systems work together, that's like almost more important. And then actually, if you want to do it for real, you do need to actually get down to the numbers to actually make it happen. It's a bit like it's one thing to kind of like understand an algorithm, but you then have to code it in Pascal. You have to do the damn thing to make it actually run. Otherwise it's just not going to work.
Yeah. I don't know. I think I'm cool with being on the level of understanding and appreciating and letting the experts do the work. But yeah, I do wish there was an intermediate. I wish even in high school that there had been some kind of level that was, you know, for people who are really curious about how things work, but aren't into the math side, to just go and like do the experiments and run the marble down the hill and you know, stuff like that. I think that would be fantastic, but you know, nobody asks me.
It's almost science appreciation, much like you can take an art appreciation course, right? You don't actually learn how to make art in an art appreciation course. Right. But you learn how to appreciate it. And the same, you could almost do mathematics and science appreciation, even if you can't actually work, if your brain doesn't work so that you can actually understand the numbers. And yeah. And what's really interesting is like actually software is actually much more like logic. You have to know logic to make it happen. You don't actually have to know numbers. Like my calculus, and even for God's sake, even you don't use any basic arithmetic when you're doing software most of the time. You just let the machine do it, and you know, it'll do it at scale and generically. You just know when this number comes in and that number comes in, you have to multiply the two of them. And you're just like machine, multiply those two when they come in. Done. Nice. But you do need to care about like all the logical difficulties of doing that. And when those two added together is going to either be 0 or infinity effectively to the machine, what are you going to do about it? Right? You need to kind of like understand the logical consequences of what you do.
Yeah, because there's big difference between those two things.
Yeah. But the machine doesn't know squat until it actually gets those things in. And if you don't tell it to fix those mistakes, it will just do whatever you tell it to and then just plow on forward.
Right. Garbage in, garbage out. Yeah. So since you mentioned music, and that was the other thing that I wanted to talk to you about, and because I remember, you know, you were always making stuff up on the keyboard and in every musical in middle school and high school and all of that. I'm kind of wondering, first of all, like how those interests competed back then. You know, did it kind of, was it a huge decision for you to decide that you wanted to do computer science rather than music in college, for instance? I mean, how did that all come together?
So yeah, there was a choice. There was a point at which I needed to make a decision. Actually, I cheated in with respect to kind of like your question. So the, the moral of the story. So actually, I have two data points as to how I made this choice actually, and I don't regret the choice.
Mm-hmm.
In that in high school, I had a voice teacher who I said, I'm thinking about maybe majoring in music, and he said, don't do it.
Mm.
And he said, look, what I mean, and I think my face fell at the
Right.
time, and I was like, what do you mean? And like I think, and he said, look, if me saying that is enough for you to not do it, then that's probably right. He said, this job and being a professional musician in any way, shape, or form is so damn hard and doesn't pay anything.
Mm-hmm.
So if you can do anything, do it. You
Mm.
will have a better life. And I think he was just being, and he said, and use all your free time to do whatever the hell you want, including as much music as you want,
Mm-hmm.
including whatever you want to do. And like, and see the best stuff you can. Like he's like, I can't afford tickets to go see like everything I want to see,
Mm-hmm.
but like, so as a result, like I'm a software developer in a major city, and I can afford to buy tickets to like world-class
Mm-hmm.
performances all the time. And I can be like, oh yeah, let me buy that $200 piece of software for playing with synthesis today.
Mm-hmm.
And like, just not, it's okay. Like that's, I can't do it every day, but like you can do those and it's not a problem. Whereas like a musician be like, okay, I need to pinch my pennies to be able to like
Mm-hmm.
get my $200 to be able to like do it. And so that's one point. The other thing I think that happened to me was, went to, that summer camp, that Pennsylvania Governor's School for the Arts in between my, junior and senior year. And in that, it was pretty much an intense summer only program of effectively what was a music program at that time. And it was actually just any arts, but I was in the music one. And first of all, I found myself taking a whole bunch of like maths related work, like synthesis and like composition and the theory of electronic music. And so I just gravitated immediately towards the like math stuff.
Mm-hmm.
And then the other thing I just remember at the end, I was like, I miss doing hard math problems. Like,
wow.
After that. And I was like, okay, there you go. Like, that's probably my life is going to be better if I do the stuff that actually, as crappy as a system as it is, right? Capitalism will reward more the like practical as opposed to the like creative. Also probably, I mean, it's also a supply and demand thing. Like everybody would love to just be creative their whole time. They're like pure creativity, as opposed to, and then I realized, oh, actually, if I do this right, I can do applied creativity, if I can get away with it. So for a while there, I was actually toying with the idea of going into like music engineering. So like studio work and being the person behind the desk,
right,
and being able to understand the technology. I even took physics to a relatively high degree, so that I even took like a class in like acoustics in physics. Oh my God, that to this day is the hardest class I've ever taken in my life. It was three-dimensional calculus derivations that took 3 or 4 pages legitimately of like proofs to actually resolve, because they were really hard problems, and I only got them right a small fraction of the time, which was enough to get me an A in physics. Physics is a ridiculous major, because it's so hard and it's so like difficult, that the curve is off the charts weird. And if you make a passing fly at it and you get your friends to help you, when you actually do it for real, you have peers reviewing you all the time, and you don't do your work by yourself. Anyway, so I was trying to split the difference. And then I realized actually, I actually enjoy the creativity of applied engineering, straight up, and it pays better, and I can still do theater in my spare time and have a guitar and, have an iPad app that allows me to do sequencing and music composition while I'm on the plane in between my work, so I'm still playing with that stuff. But, and what's interesting is, I have some friends in London who flirt with, like, they're semi-professional theater people. And they, the tough part about that is they can't choose their jobs. So sometimes they have to do the crappy pantomime gig that over Christmas, and they have to play the same show like for 3 months in a row to kids doing stupid fart gags. And like, that's how they pay the bills.
Right.
Whereas I'm like, in the amateur world, I'm like, I don't want to do that show. I'm going to do this show over here, or I'm going to like delve into my own stuff for a little bit. So I end up like creating a space to be able to be creative, in the way that like I want to. And I actually find that throughout my life, that when I've been worst off is when I don't feed both sides of my brain.
Yeah.
When I go too deep in one way, actually most of the time, of course, my job is going to pull me more towards the practical. But if I don't keep the right blend of the creative in there as well, that it will stagnate, and I won't feel at ease doing it, and it'll feel like it's real work on the engineering side, and it's not the kind of job I want. So I really try to find that blend of the creative and the technical. And if someone only wants the mechanical, then usually that's not a highly competitive job, and that's usually not a super interesting job, and usually that's not where you want to be anyway. So the best jobs are actually the ones that require you to kind of think outside the box pretty often, right? And that's innovation. They just call it innovation in technology, right? But it's the same thing. So
it's interesting hearing you say that, because I don't think I've ever noticed the one or the absence of one affecting the other. And I mean, what I do is not technical in the same way as what you do, but there have definitely been times when, say, I haven't sung with a choir for a couple of years, and all of a sudden it's like I reach the breaking point, and it'll hit me out of nowhere. And it's like, whoa, I got to go do something about this before I lose my mind. So yeah, I think it's probably,
I don't know what your symptoms are when that happens. Like, I end up being a bad person. I end up like being wound too tight. I'm not graceful with my problem solving, just in general, through all aspects. And usually being able to push it creatively means that, at least to be able to get a creative outlet means that I can apply, my mind is usually at like a problem solving, open, kind of a little bit more easygoing, a little bit more adaptive way. And if I don't get that outlet, like almost everything else becomes more rigid and seizes, and I'm just not as creative in just about everything, including like just plain old conversations with people. How I solve. I mean, we all solve problems at work, right? And like the more creative, the more you might find another way around a problem, even if no matter how simple the problem is. So yeah, I feel like if you don't constantly work the creative side, you're not going to be able to achieve what it is you need to achieve in any realm. And so I find that blend actually helps a lot.
That's really interesting, because I've never let it go long enough to actually codify what happens. I just kind of realize this sense of general malaise, and that I need to do something about it, and go do that as soon as humanly possible. But I wonder how often that happens to people and they don't even realize that's what it is.
Yeah, that would be really interesting.
Yeah, because I mean, we deprioritize the creative in our culture. So, you know, you go to work and you're an accountant all day, and my cousin, the accountant, is going to hear this and scream at me, but she'll have her interview later. But, you know, if you're going to work and you're an accountant all day and you're just using that part of your brain and you're not doing the other things because you've written them off, or, you know, people have said, oh, that's not that important, or just be happy you're making all this money as an accountant, then you might not actually notice as easily that thing is missing, and that it would actually be really beneficial to go do it again.
Yeah. And I think that's where probably because I miss math if you don't give it to me for a while. Like I can sustain and be happy and functional in society, supposedly, without creativity. But then I really notice that it doesn't, it affects even that ability. So especially as you get later on in your career, when your problem solving needs to become more abstract as you go, right? The problems that people give you are bigger and hairier and nastier. And therefore you need the creativity to be able to like kind of solve it, not mechanically, but kind of a little bit adaptively, whether it be because of people or situations or like your resources that you have at you. So, you know, unless you're in a ridiculously controlled and totally uninteresting job, like that, which I don't think, I mean, that's going to be a lower paying job, right? That's going to be a little bit mechanical, even if it's in information technology. If you are an accountant and really you're just shifting stuff from an inbox to an outbox, then I would actually say you're not really doing accounting. You're just doing mathematics. Right. And actually, usually accounting is applying some kind of logic on top of all this stuff. So, and the more senior you get, the more like, let's not talk about creative accounting. That's not actually what we're talking about.
Right. We are, but not that way.
Yeah, exactly. Creativity in the way in which you approach those particular problems.
Yeah. Which is why I want to talk to her too. But But yeah, so we're kind of like semi in the territory of what I wanted to ask you next. But I'm curious to know, you know, really how the two have fed each other for you, especially because, you know, you hear people talk about how music is so mathematical, which is not something I've ever, I mean, obviously, you know, you've got a meter and you have rhythms and things like that, but I've never really delved into exactly what that means, but maybe you have, I don't know. But I'm curious to know if you've seen any relationship between how the technical influences the musical and the creative and vice versa for you.
Well, so I can talk at length because of those classes on like synthesizer theory and like I'm doing basic synthesis. And then ever since then, like I'm totally fascinated by the fact that music is nothing more than like tickling our pattern recognition system in our brain. Even tonality even a major chord is self-reinforcing both mathematically, and then therefore it tickles a pattern recognition system. That's why like an octave is an octave and a major chord is a major chord and like a minor chord is a minor chord. That like there's a mathematical reason why you can explain all this stuff. So it's extraordinarily I think almost all of this is like, when you get fundamentally down to it, it's technical, but then what's really interesting is it elicits an emotional response because of the way in which our bodies are tuned to understand those things as intrinsically good or bad, because like a self-reinforcing pattern is like elegant and interesting and like naturally like self-strong in some way, shape or form. Right. So like, that's why music is interesting, and some kind of also we love repetition, but we also love when it breaks. So the best music, like a hook, is almost the definition of a hook is almost like a pattern that repeats, but then like catches you with its like anti-pattern in like a totally interesting way. Right. And you find that like fascinating, and you can't get that like both the pattern and the breaking of it like out of your head. That's almost the definition of an earworm. Right.
Right.
And like, Um, so anyway, so just knowing all of that stuff, right, is kind of the way in which you can. I mean, this goes all the way down, right? It goes to the way in which you see that software patterns that are self-reinforcing are like elegant, and then occasionally there are things that break them, and like you need to pay attention to them, and those are important. And so those like become the kind of like the hook of the problem that's kind of interesting. um, there's ways in which you need to creatively solve a problem, and you need to deal with creative types. So sometimes actually software engineers can be just as temperamental as any musician in the planet, right? And you need to kind of like, because they believe that, and I think rightfully so, they cast themselves very much as creative, particularly if they're in the like really the more scientisty they are, the more they kind of like want to explore new things. And so I think the scientist who's like craving learning new stuff about the world is just using like mathematics and physics in this to seek out new truths, just as like an artist kind of is, but on the like economic, social commentary kind of some other way. Like I think they're both trying to seek out truth, and therefore they both need to understand how it is they're going to get to it, like through some kind of like process. But they also need the capacity to be able to like think laterally, to be able to or expansively. The mental model that always like, I always think of myself as I'm trying to solve a problem. I'm in one of two modes, and I kind of oscillate between them. And I usually am trying to kind of trying to actually play those two modes off of each other in an interesting way. Incidentally, as a side note for this, read an article once that was saying that the difference between like some of the best musicians in the world have an amazing mental model of their instrument or the music that they're playing. And so if you actually talk to them about like how they think about it, they've got like some kind of mental visualization of like the piano or the guitar or the song structure that they're like really trying to put together. So anyway, my really, really simple mental model, I mean, I think I've got like layers on top of it now, but I usually try to think about problem solving it's either I'm going to try to like narrow, focus, prove, mechanistic kind of like actually just do the work, like technical charcoal strokes on the canvas, right? Or I'm thinking kind of laterally and expansively, and I'm like, okay, what if I break this, and what's not like this, or like give me a reason why this wouldn't work, or like and you're throwing creative thinking at the problem, trying to like break loose the solution that you don't yet have, and you kind of have to like oscillate between those two to actually get to either a painting or like a technical solution that is truly interesting. I mean, there's the shame of it is that there's truly tons of good, well-paying jobs in the technical field that don't require you to do any of that level of sophistication that I'm doing. But that's not innovation. That's mechanical. And I'm not taking anything away from that. It's just that's a different personality. That's not what we're talking about today, right?
Right. And you're reminding me that the choir that I sang in college was open to anyone from the university. So you could be an English major like I was, you could be a theater major, you could be a computer science major, you could be an engineer. And it was kind of amazing how many engineers there were in the choir.
Absolutely.
And and my dad is an engineer, and he's been a choral singer since forever, which is part of how I got in there. And I think there really is something to that. I wonder how many musicians there are who are also engineers. Oh, it's got to be really high.
It's huge. Yeah. No, it's amazing, and a lot of them will have like a technical bent. And particularly, what I find really interesting is because I've done like both theater, like I've done theater, but I'm mainly coming at theater as an outlet for like music. Although I do appreciate it from like its artistic bent. I think my inherent nature was coming at it from music. So really, it was the mathematical kind of it tickled the same stuff as the mathematics. Whereas I think if you start really first from the creative, then you've got your visual artists who then kind of at theater, and like that's kind of a little bit more where it kind of meets a little
Mm-hmm.
bit, because theater can be so technical. It has a lot of like logistical stuff, and it
Mm-hmm.
actually has a lot of technique, and it has a lot of yeah. But what's really interesting is you can really totally tell the mathematicians who know music certainly know how to read it, certainly know a lot about the technical of it, whereas the creative people who came at music, they usually don't have theory.
Mm-hmm.
They usually they've instinctually approached their
Mm-hmm.
instrument. And the answer is like both approaches work really well. And I think when you really break it loose, you kind of know how to use both of those techniques.
Yeah, because I had a little bit of theory. I took piano lessons for 3 years, and that was as much theory as I got. And every once in a while, I toy with the idea of it. I never really get that far. But I remember asking a music teacher when I was teaching, and said, how is it that, because I sight read really well. I said, how is it that I sight read really well when I don't know theory? And he said, you probably read harmonically. And I'm still not exactly sure precisely what he meant by that, but I guess that I just knew where it was going to go, like instinctively, and that's what I was doing.
Roughly the distance and what it should be, and then also your ear probably fit it into the next chord structure.
Yeah.
Whereas what's really interesting is I think the people who really know theory will tear apart the line of the music to understand how it's theoretically moving, and they'll know their part in that theory as they go. So this is a level. This is actually a really good example of like the mental modeling that truly can happen with amazing musicians. Is they'll understand the chord structure, and they'll understand how their line fits in that chord structure and why that chord structure is the way it goes. So, for example, they know. I mean, this is one of the simplest techniques of songwriting trickery in theory, which is the relative major and minor. Is that like a C chord, which is all white notes, is exactly the same as an A minor chord, which is all white notes. And so in theory, those are kind of the same. It's just a matter of where you root them. So those are actually the same chord. Those are actually the same kind of notes, and actually the difference between a C major chord and an A minor chord is just one note. It's an important one. It's the fifth versus the tonic of the one. So just knowing all of that and keeping that all in your head and kind of like figuring all that out, and then letting the instrument kind of help you with that as you go, and like helping the music kind of go as you go. Like all of that is it's just amazing, the mental models that you can get in there. And so actually to be able to know enough about the theory, it's a bit like a truly masterful artist knows how to use all their tools fantastically, such that it disappears, and now they're at a different level, multiple levels up from the mechanics, and they're just automatically applying the mechanics. As I'm learning guitar, I'm occasionally trying to be brave and learn a John Mayer song here and there. And actually, the thing about him that's absolutely stunning is, first of all, he writes very classic kind of chord progressions in his songs to root them, to kind of, almost all of them are very centered. Like if you break it down to its very simplistic theory, he's actually doing a lot of very simple stuff. And then the complexity just immediately starts layering on. Like then he's using some like weird variant of that chord to kind of get this additional sound that's super interesting in there. So he's not actually following 1-4-5. He's like he threw a minor second in there. He's doing all these other things. And then he uses the guitar to kind of like screw with all the variations that you could do of that chord. And he's playing up the neck to kind of get all these really cool inversions. And then he makes it simple again on the instrument, where you like actually realize how he's playing it. You're like, oh my God, that's so simple. And then you learn how to play it his simplistic way. And then you hear him do it live, and you're like, oh my God, he just started there. And then he went crazy, and he understands his instrument so well that he like broke it down again into simple, and then he took it to complex again. And you're like, ah. and that's why that's all these like layers of this kind of theory. Like he's alternating between like the theory and the art, and just constantly playing the two off of each other to get to that level. And I think some of the best art, actually, you can see the interplay between the creative and the technical, and then you can see it kind of like come and go and like oscillate between those two kind of modes. That is so fascinating.
And that's right back to art appreciation again.
Yeah.
Because if you don't know enough about what you're talking about, you'll never see it. You'll never hear it. You'll have no clue. You'll just say, "Oh, that's nice," which is kind of how I feel if I go to MoMA.
and there's nothing wrong with that. That's a pretty reasonable, like that's the emotional kind of ultimate bedrock level. Like, so nobody's saying that doesn't exist. It's just if you then also understand the techniques it took to get there and all the thinking behind there, then that piece has that much more weight. And you understand all of what that took to get to that.
Yeah. And I usually don't have that, even with a piece of music that I know well. But I was talking to Donna Fortunato a couple months ago, and I said to her, I wanted to do. I heard Ralph Vaughan Williams' Dona Nobis Pacem on the radio one time, and was just like, I couldn't get out of my car because I was like, what is this? And so I wanted to do it, but nobody around here was doing it. I picked up a copy of the score for myself for my birthday one time, when I was at the Princeton University store when they used to sell sheet music. And so I had it, but I can't do a piece for orchestra and 4-part chorus by myself. That's kind of hard. And then Westminster will do these summer sing-ins where usually it's something like the Fauré Requiem or, Beethoven's Mass in C or something like that a lot of people know. And so people just show up and you run through it. You're not going to learn it if you didn't already know it.
Right.
But they did that one night. So I went because I was like, I'm finally going to get to do this. And I hadn't realized that, when you don't know it, I stumbled through this piece for an hour and it was so frustrating. It was like being torn between, I finally get to do this and this is just chaos in my head. I have no idea what I'm even trying to do. I don't even know if I had listened to it recently before I went. But then a couple of years ago, I finally got to actually sing it. And when you sit down with it for 3 months on a regular basis and you start learning the notes and learning the part and putting it all together in a rehearsal and sitting down and listening to the recording. So now you can hear what it's going to sound like when you all figure out what you're doing. You really get into this nitty gritty. It's like you get inside it in a way that you can't do just by listening to the CD or by going to the sing-in where you hope that other people know it. I don't think they've ever done that one again. I think for a reason, but, and it just becomes a completely different experience, a completely different piece because now you're sitting in the middle of it and you know what's going on and all the little bits that, the piano or the violin or, the little bass line over here that you really love and appreciate that you wouldn't have noticed before, which is a completely different angle from what you're talking about. And yet I think it's really the same kind of thing.
Yeah, no, it's exactly the same. Like the more you know, the more that you can kind of, you can get to another level of artistry by appreciating the technicalities. And I think it's that kind of going back and forth between the creative and the technical that I think is actually like everybody does.
Yeah. It sinks into your bones.
Otherwise that if you don't put any technical in, it's kind of the definition of like punk art, right? Like which isn't to say that isn't a thing, but then that becomes like the attempt there is to remove all the technical and push it almost all to pure emotional. And what's really interesting about that is like actually you can tell bad punk art from good punk art because there's only a few people who can really tap into that emotional so well, so consistently, because it's almost harder than like being able to kind of blend the two of them. And then there's a few people who can like lever, like truly amazing jazz musicians are just thinking at like multiple levels. Putting this Jenga tower together between the technical and the artistry at multiple levels, to be able to kind of work a song in a way that you've never heard before.
Mm-hmm.
Just because that particular time they just went, what if I turn left instead of right on this particular thing? And they follow that instinct, and they managed to find a new interesting path because they routed through the song in a slightly different way.
Yeah, because they know it well enough to be able to see where they can do that.
Yeah. Yeah. And or they're confident enough in their abilities that even if they're going off road, to extend the analogy a little bit, they can find their way back. The best jazz musicians are can almost take almost any chord, and they can get you back to this in your 3 measures, get me from here to here, and they'll find a way. And you're and here's what the song's doing during those 3 measures, and you got to find a way back from your abstraction that you just went to back to the actual melody, and they can do it, right? Which is a hell of a thing.
That's amazing.
But they've got a combination of technique and instinct that gets them through that.
Yep. I'm loving this because I don't really get to think about this kind of stuff this deeply all that often. So I'm looking at the clock, and I know we have to wrap things up, but I don't know. I guess I'm wondering, how is the feeling of the creative process for music for you the same as the feeling of software development when you really get into it, or do they hit you on 2 different levels?
I'd say that with the brilliant thing about most forms of art is that they encourage you to get to the abstract process quicker, and therefore you can be staying at this level of that. I mean, very few people use software as a medium to create art, and one would say that almost even those who do, they're kind of using software to drive something else that's creating. Nobody's create. I mean, I guess there probably are some people who are who can write some code that in some way is artistic in and of itself. But I think that's because the medium doesn't lend itself. We don't have an infinite number of mediums for expression of art.
Right.
And I think that's because those are the ones that actually let us live in that kind of realm more easily. Whereas actually fundamentally when you play with software, eventually you are just going to you're going to take some data and you're going to put it over there. You're going to do something different with it. It fundamentally it's work. Whereas I think the mediums that we have for other things are more abstract and let you play at that level. And I think that's the difference. I think you want to apply those kinds of multiple modes and the creative mode to your technical work or to just work in general. But it doesn't, so you think about it differently because ultimately you're being really practical when it comes to work. You're just applying creativity towards something that's practical. Whereas I think, your ultimate goal in the other one is actually just pure enjoyment. And if you actually don't accomplish anything other than the art form, that is actually the goal. So I think that's where you actually, so when you get deep into the creative thinking and trying to solve a problem as abstractly as possible in almost any job, you should be at this creative kind of melange. But fundamentally, you're not going to go up on stage and do it in a really interesting kind of artistic manner.
You don't think that's the next reality show?
No one's going to buy a ticket to see it. Well, I think that's the thing is actually there probably could be. I mean, somebody probably could, right? I'm sure somebody has created. I'm trying to think of there's plenty of things where people have created art with really strange mediums, but the problem is that actually takes a very specialized understanding Whereas I think most of the things like music, if you were trying applying creativity to that, it's a lot more base. It's a lot more like you're much more worried about that visceral reaction that you had when listening to a piece of music. That's what you're trying to evoke. So your ultimate goal is very different. And so both are extraordinarily focused on the goal, right? I think doing a good job means you're focused on what it is you're trying to accomplish.
Right.
And I think that's the fundamental difference. Is the one is for pure joy, and you're trying to focus that. The other one, you got to get the joy of using creativity, but like the fundamental thing you're trying to do is actually very practical, and you can get yourself all excited about the creativity of your job, and you should. But when push comes to shove, you have to do the thing.
Alrighty. Well, that's an awesome place to stop. So
yeah,
I think we'll do that. But thanks so much. This has been a ton of fun and really interesting on a level I didn't even expect. So
well, you're welcome. You're welcome. It was, I really enjoyed it as well.
That's our show for this week. Many thanks to Michael Smith for such an intriguing conversation and to you for joining us. Be sure to check out the show notes at fycuriosity.com. And if you enjoyed this week's episode, please do share it with a friend. Thanks. You can find show notes, the 6 creative beliefs that are screwing you up, and more at fycuriosity.com. I'd also love for you to join the conversation on Instagram. You'll find me at fycuriosity. Follow Your Curiosity is produced by me, Nancy Norbeck, with music by Joseph McDade. If you like Follow Your Curiosity, please subscribe, rate, and review on Apple Podcasts or wherever you get your podcasts. And don't forget to tell your friends. It really helps me reach new listeners. See you next time.